Chapter 5 is on the various commands and concepts that have to do with Unix security. The first of these concepts is to note that Unix is a multi-user operating system, and that's exactly why we need security. We will be sharing the computer, in other words the various files on the computer and other resources, with many other people, and it is entirely possible that one of those other people might do something accidentally or deliberately that we don't want them to files that we feel are under our control. This is a pretty widespread phenomenon, as you're probably aware, and so the notion of security was invented for the various files, directories and other resources that we have on the Unix system. That's what this chapter is about. But first, what does it mean to say that Unix is a multi-user operating system? I know what you think it means, but what does it specifically mean? Well, the actual definition is in two parts. The first is multiple people may be connected to and running programs on the system at any given time. In other words, multiple people are capable of logging on simultaneously. But that's not all. It's not enough to say that there are multiple people logged onto the system at any given time. Also, we must also say that each of these users has a separate set of access privileges. So depending on how each person identifies themselves to the operating system, they will get different permissions to do different things on the computer. So if I log in as me, I'll get permission over, say, my files. And if I have somebody else's username and password and I log in as them, then I will not have the same permissions as I had before to access my own files. I'd probably have access over their files instead. So, are all operating systems multi-user? Well, clearly no. I mean, DOS is the obvious example. DOS allows only one person to log on to the system at any given time. Well, they don't even have to log on to. It's just one person is using the system. And there's only one set of access privileges. Everybody gets the same set. No matter who sits down in front of the computer, everybody is allowed to do the same thing. Essentially because there's no logon procedure to identify different people. But what about some of the more sophisticated operating systems? And I will speak now of the common variants of Windows, because I'm guessing that some of you may be familiar with Windows. So let's have a look at a little table of those. Unix, as we can see, is fully multi-user because it supports simultaneous users, each of which has separate privileges. Now, with the advent of Windows Terminal Services, which is an addition to the Windows NT family of products, Windows 2000 and Windows XP are now able to support simultaneous users on the one computer, all logged in. And I'm not talking about networking sharing of files. That's simply making files on this computer available to another computer. And that's not the same thing at all. This is people logged on to this particular computer, running programs in the same memory space as other users. So Windows 2000, Windows XP, yes, it fully supports simultaneous users with separate privileges, and so is a true multi-user operating system. However, its predecessor, Windows NT, which did not have the Windows Terminal Services feature, was only partially a multi-user operating system. Each person that sat down at the computer could identify themselves to the computer with a logon name and a password and would get separate privileges over the files on that computer. However, only one person could do that at any given moment, and so it wasn't really a true operating system. Now, a lot of you will be using Windows 95 or Windows 98, and you will be seeing a login screen occasionally when you log in, when the computer boots up, for example. So you might go so far as to think that your Windows 95 or 98 system is a multi-user system as well. Well, not really. It isn't really in any true sense a multi-user operating system. That is because only one user can log in at any given moment, and each user that logs in gets the same set of privileges as any other user. At least, that is, privileges over the files and resources on that computer. On the network it may be slightly different, but I'm not talking about a network environment here. I'm talking about just this computer. It is true that in Windows 95 and Windows 98, each user that logs on gets a different configuration, a different set of settings, if you like, but that's not really anything to do with multi-user operating systems. Core to this particular chapter are two specific concepts. One is called a user. Now, most people are probably fairly familiar with what a user is. It's simply a system identification that allows each user that logs in to identify themselves for resource access purposes, in other words, for security purposes. So what that means is if we're going to have security on the system at all, if we're going to make sure that the right people are able to perform their actions in the right way and the wrong people are not allowed to, then we have to have some way of identifying who's who. That's what a user is. It's typically a short string of characters like Fred or mVirtue. Incidentally, recall that root is also a system ID. It's a user. It's the special user that has permission to do anything on the computer, has access to all resources. And when I say resources, I'm talking mostly about files. Well, files and directories, of course. But in Unix, as we'll see in a later chapter, it is possible to access all sorts of other devices that are attached to the computer, such as printers, tape drives, floppy disks, CD-ROMs, etc., etc. And each of these has similar permissions to a file, similar resource access permissions to files and directories. So I'm just bundling them all under the one heading of resources, but it's mostly going to be talking about files. Anyway, so a user is one main concept. There's a second main concept that we need to talk about as well briefly, and that is called a group. It's fairly easy to imagine a scenario where 50 different users all require an identical set of permissions because they're all part of the same team or part of the same department or what have you. Now maybe they all have individual permissions over their own files, but they also might want to share files. So what we do is we make each user a member of a particular group, and that group might be named after their department, such as the sales group. And if the sales department wishes to share documents around itself, then they can specify various permissions for that document as far as the group is concerned. So we could say that the group has permission to read this file, the group has permission to modify this file, and thus any of the members of that group inherit those permissions. The upshot of all this, for example, is that if you have a file that is able to be modified by the sales group, then all the users that are members of that sales group are thus able to modify the file.